This is Nick Hodges, the Delphi Product Manager, and welcome to another edition of Turbo Delphi Demos. Today we're going to talk about inheritance. A couple of demos ago I showed basic encapsulation of a class in Delphi, and now I'm going to show inheritance. Of course, the big three pillars of object-oriented programming are encapsulation, inheritance, and polymorphism. And today we're going to cover that middle one, inheritance. Now I'm going to open up the project that we worked on last time. If you're viewing this and you haven't seen the demo labeled basic classes, please go find that one, watch it a little bit, because the code I'm using here was the code from that class. From that demo, I created a basic class called tPerson, had some fields called first name and last name, and then I had a little function added onto the property that created a full name from first name and last name. And what that illustrated, of course, was encapsulation, was that a class can encapsulate data and functionality into a single entity. Now, another cool thing about object-oriented programming, object-oriented development, is the concept of inheritance. And what inheritance is a principle that states that a class can pass all of its functionality onto a descendant class that then implements its parent's functionality as well as additional functionality. So descendant classes generally specify or become more specific types of the general class that is the parent class. So for instance, we have tPerson, and we might descend from tPerson and create a tEmployee, because of course a tEmployee is going to be a tPerson and have a first name and a last name and whatnot, but it also might have, say, an employee ID number, which would be, say, an integer. Okay, so now we've created a new class called tEmployee. It has all the characteristics and functionality of tPerson, but adds the attribute or the field employee ID. Okay, so now I can come down and I'll just alter this code a little bit so we can see that we can, well, actually I'll leave tPerson there because we're going to use that here in a minute. And then I'm going to create, say, an employee of type tEmployee. I can declare that, and I'm going to come down here and just do a little additional code from what we had here before. I'm going to put a try block in. I'm going to put try finally, use my little code completion here, or my templates, and I'm going to create an instance of employee, gets tEmployee.create, because remember we always have to create objects, and now I'm going to remember to free it in the finally block, which will guarantee that no matter what happens inside the block of code here, the employee instance will be freed from memory. So now I can do what I did before here. I can still set, you'll notice that employee, because it inherits from tPerson, still has first name, and I can put in Fred, and then I can still say employee last name gets our trusty Flintstone, right? And then I can say, do the right len, employee name is, well, actually, I'm sorry. Now, because we've inherited from tPerson, though, and it added some functionality, we can get the employee ID is, we'll just, whatever, 12. So now we can come in here and say full name, which will get the function, again, whoops, I'm sorry, employee dot full name plus, and then we'll say full name double, let's see, 1, 2, 3, S is, what I'm trying to do is put an apostrophe at the end of this guy's full name, which I have done now. Whoops, employee ID number, sorry, is, and then we'll call a little simple function here called int to stir, which is part of the runtime library, the simple basic runtime library. Employee ID. Let's close this up. We don't need these two. I'm unpinning them so now they're available to me as they pop out. but I get a little more coding room here. So now I can say the employee's full name, and because employee inherits from T person, I get the full name function, even though employee is not employee is a person descendant. And then I say it's his employee's number is, and then I'll output the employee ID, and I free up the instance. So now we can save it and run it, and I get an error. Oops, I left out a closing parentheses. So now save and run, and you can see the first part about just regular person, but then it said Fred Flintstone's employee ID number is 12. So basically, that shows a very simple example of inheritance, i.e. you have a person object that has certain functionality, but you want to make a more specific type of person, and that is T employee, that is descends from T person. And I've added a small field. I could add addition functionality. I could, in fact, override the functionality of full name, to enhance and augment and or enhance that functionality. So, for instance, for all employees, we want to be a little more respectful. We'll override how the full name functionality is implemented, and we will add this word at the end of the function called override. Now what that means is that the inherited class, i.e. T employee, will provide its own implementation of full name functionality from the inherited version, so that when employee calls for full name, it will run the employee version of full name and not the T person instance of full name. So I'm going to override the functionality of the parent class and provide a new set of functionality. I'm also going to hit Control-Shift-C, which will create for me a stub for the instance. And what I want to do here is I want to say, well, the result equals, we'll call all of our employees, we are very polite here, we call all of our employees associate, like associate Fred Flintstone. So all of our employees have to have associate in front of their full names. Now, there's no sense, one thing I could do here, of course, is I could just say first name plus a space plus last name. And that would work fine, right? That would work just Jim Dandy. We can run it in, I'm sorry. If I want to override something, I have to declare the parent, I have to declare the parent class instance virtual, and virtual means a function that can be subsequently overridden in an inherited class. So once I declare full name as virtual, then I can override the functionality in an inherited class. Okay, so now I can run this, and I should see associate Fred Flintstone's employee ID number is 12, right? And that works. But you'll notice that this code here and this code here is really actually the same. So actually, in order to kind of ensure that the inheritance chain is properly kept up, I can say result gets associate plus, instead of reproducing that code, I can actually call the inherited full name function, and it will come along, it will take the associate, it will add it along, it'll find inherited full name, and it'll go, inherited full name. I'm going to go up to my full name functionality that I'm inherited, and it'll add on the result of this function call because I called inherited full name. Now if I save it and run it, you'll see again the employee's full name function is called, but inside the employee's full name function, the person's full name function is called. The inherited functionality, the functionality inherited by T employee from T person, will return good old full name Fred Flintstone here. And again, of course, the inherited functionality of the employee ID number as well. So let's review that again now. We declared the full name function as a string, and we added this reserve word here, virtual, which tells the compiler that will be a function that we will override in a descendant class. We have T employee, which descends from T person. There's a connectivity issue right there, right? They're connected. And the T employee class adds an employee ID number, so we can keep track of employees as not just regular people. Now, for instance, just to show how this descendant trees as a little bit of an aside here, you might declare T customer, right? And the customer might descend from T person as well. And then, for instance, you might have a customer ID number for the customer. And you might also have other information about customers that you would want to keep that you wouldn't keep about employees, for instance. Like, for instance, an employee might have a salary, and that would be a double, for instance. And a customer might have a collection of orders, or another class of collection of orders, or other information that you would do. So, okay, anyway, so when we override full name, again, it overrides the virtual function here. So that's the basics of inheritance in Delphi for object-oriented classes. Just real basic. Employees descend from T person. T person provides a certain amount of functionality. That functionality descends along with the T person class into employee, and you can actually augment and override the functionality of T person. So, for instance, just again real quick, you might have this might be monthly salary, right? And then we could add a function called calculate yearly. A function here, sorry, would be a function called calculate yearly salary, and it would be a double as well. And then I could go control. Whoops, I won't be able to do that because I got to put a space there. And I could go Control C, and then of course result equals monthly salary times 12, and you'll get a function on employee that you wouldn't want to have on a person, and you certainly wouldn't want to have it on a customer either, right? So the inheritance chain there allows you to create specific types of persons, all of which have common functionality, right? Customers are going to have first names and last names. Employees are going to have first names and last names, but employees are going to have employee ID numbers, and customers are going to have customer ID numbers, that kind of thing. Both might have addresses, where you would create another class called address, and you build a class called address, and then you could add that to person. So then, if you add a function here, of course, say we'll just use address as an example as a string. If we add address as string, now at the T person level, both T employee and T customer will get address. They'll both have address. So now I could come down here if I wanted to, and I could say, person dot address, and then we could say Michael Jordan lives in Chicago, and then Fred Flintstone. We could say employee dot address gets, he lives in Bedrock, right? Okay, and so you can see that adding functionality to parent classes causes that functionality to descend to all descendant classes. Okay, so that wraps it up for today's edition of Delphi Turbo Delphi Demos. Thanks for your attention, and we'll see you next time around.